You're listening to the N2K Space Network.
This episode is brought to you by Palo Alto Networks, the leader in cybersecurity. As AI-driven attacks increase, organizations can't afford to have network security that's stuck in the past. Discover how Palo Alto Networks can help you predict what's coming and proactively secure against it with a zero-trust, AI-powered network security platform built to secure whatever, whenever, wherever. To learn more, visit paloaltonetworks.com/network security platform.
We've all been there. You're in such a rush to get where you're going, your foot just catches on a rock that you totally could have sworn just came out of nowhere and, faceplant. Real smooth. Hope nobody saw you. Pretend you were tying your shoelace. Oh, everybody in the entire world saw you? Oh, it's okay, Odie. Just say you totally meant to do that.
T-minus 20 seconds to LOS speed rest. Go for deploy. Roger roll.
Today is February 26, 2024. I'm Maria Varmazes, and this is T-minus. Odysseus is seen in first images on the moon. Japan's Slim woke up after the lunar night. China launches a communication experiment satellite. And our guest today is Matt Shieh, CEO and co-founder of Canopy Aerospace. Matt shares his opinions on supply chain and advanced manufacturing issues in aerospace. Stay with us. Happy Monday, everybody. And as we continue to anthropomorphize lunar landers in today's show, perhaps Odysseus got a little jealous of Jax's Slim lander and said, hey, how come Slim gets to be sideways? I want to do that too. So now we have two recent and sideways lunar landers active on the moon right now. Yes, Slim too. We'll get to that. Intuitive Machines' IM-1 mission, in the words of company CEO Steve Altimus, was quite spicy. And that feels just about right, given that the Odysseus lunar lander did successfully land on the moon, but decided to do it its own way. Unfortunately, initial reports of Odie landing upright were incorrect, and a press conference with NASA and Intuitive Machines leadership on Friday afternoon confirmed it. The lander is on its side. Though through a great stroke of luck, the scientific payloads and the solar panels are upward-facing, not on the side facing the regolith. The current theory is that Odysseus's landing gear got caught on a rock during touchdown, which then caused the tip-over. Nonetheless, Odysseus has been fully operational since it landed, and the solar panels on Odysseus will have exposure to the sun through tomorrow. That would be Tuesday. But after that, it's expected that the lander will go silent, as it won't have enough sun exposure to stay charged up. In the meantime, Embry-Riddle Aeronautical University is still working with Intuitive Machines to get the student-made EagleCam camera project, which is still fully operational, by the way, deployed and taking some photos of the lander in its current state. We don't have an ETA on deployment for EagleCam just yet, but we do wish all the students working on this fascinating problem right now the best of luck on this. We're rooting for you. And continuing our favorite tradition on this show, describing photos in an audio-only podcast, we did get new photos from Odie over the weekend, both as it was coming in for a landing and a wide-angle view from the lander after it tipped over on the surface. And for some added coolness, we also have a teeny-tiny photo from lunar orbit of the tipped-over Odie, courtesy of NASA's Lunar Reconnaissance Orbiter. It is, again, pretty tiny, but we'll link some zoomed-in versions of the photo with a handy arrow to point the lander out. I've also seen some photos doing a before and after overlay comparison of the landing area, so Odysseus then stands out as the only difference between the two. It's a bright speck with a very rectangular shadow, and it really stands out amongst the gray surface and the rounded craters. Very, very cool. And speaking of face-planted lunar probes, told you we'd get to it, Japan's Slim has unexpectedly survived a lunar night and reestablished communications with the Earth. The smart lander for investigating Moon touched down on the lunar surface last month and was not designed to survive a lunar night. But in a post on X, the Japanese space agency known as JAXA said a command was sent to SLIM and a response was received, confirming that the spacecraft has made it through the lunar night and maintained communication capabilities. A further post on the social media platform said this: communication with SLIM was terminated after a short time, as it was still lunar midday, and the temperature of the communication equipment was very high. Preparations are being made to resume operations when instrument temperatures have sufficiently cooled. Don't y'all love an overachiever? We sure do. Over to China now, and a communication technology experiment satellite was launched into space from the Wenchang spacecraft launch site on the southern island province of Hainan on Friday. The satellite, which hitched a ride on a Long March 5Y7 carrier rocket, entered the planned orbit successfully. According to Chinese media, the satellite will be used for multiband and high-speed communication technology experiments. And the China National Space Administration, or CNSA, says the Long March 8Y3 carrier rocket has arrived at the Wenchang Space Launch Site in Hainan Province for the launch of the Queqiao-2 relay satellite. And the Queqiao-2 relay satellite, which was transported to the launch site earlier this month, is scheduled for liftoff in the first half of this year. It will enable communications between China's lunar rover and the ground station, providing relay support for the Chang'e 6, Chang'e 7, and Chang'e 8 missions. Over to the United States now, and the Space Force says it's making progress on its plan with the National Reconnaissance Office to enable space-based targeting and to replace legacy Air Force aircraft. The U.S. already has intelligence, surveillance, and reconnaissance assets in space, but those have traditionally been controlled by the intelligence community and are frequently unavailable when military operators need them. The future could involve Space Force Guardians working side by side with the National Reconnaissance Office. And part of that progress involves the Space Classification Policy. Recent changes to the policy will amend the Space Force's approach to secret programs and could boost cooperation with commercial industry and international allies. Brigadier General Davin Pepper, Vice Command of Space Operations Command, told participants at the AFA Warfare Symposium last week that space has been overclassified for years. From an operator's perspective, the lower the classification level, the better I can integrate into a fight. Lockheed Martin says its Pony Express 2 mission is ready for launch. The mission is intended to showcase how space can enhance combined joint all-domain command and control. Pony Express 2 is a self-funded technology demonstration that uses a pair of small satellites. Its mission integrates 4 Lockheed Martin payloads on 2 12U Terran Orbital Renegade-class space vehicles. The payloads provide a tactical communication system, a Ka-band crosslink and a mesh network, precision relative ranging and time synchronization across the satellites, and a high-end CPU processor. Pony Express 2 will launch on SpaceX's Transporter 10 rideshare mission no earlier than March. The European Space Agency and GSMA Foundry have announced a series of new initiatives, including up to €15 million in funding opportunities to help the mobile and satellite industries collaborate on developing new, innovative satellite and terrestrial networks technologies. The initiatives are also designed to help open up new revenue streams. New research by GSMA Intelligence estimates that new innovation in satellites can bring an additional $30 to $35 billion in income to the industry by 2035, equivalent to a boost of about 2 to 2.5% to the current mobile revenue base. The partnership plans to expand lab network access for Foundry participants who want to collaborate at ESA's 5G 6G hub in Harwell, UK, and 5G 6G Telecom Lab in Noordwijk, Netherlands. GSMA also plans to launch a training course to grow knowledge about and support collaboration between terrestrial and non-terrestrial networks. And commercial launch company Stratolaunch has completed a second captive carry flight with the first powered Talon A hypersonic vehicle, TA-1. The flight was the 13th for the company's launch platform, Rock, and the second in which the aircraft carried a Talon vehicle with live propellant aboard. It was also the first time TA-1 operated within the Vandenberg Western Range as part of a build-up approach for Talon A's first powered flight. . And that concludes our briefing for today. You'll find links to further information on all the stories we've mentioned in our show notes. And we've added a few extra stories for you today. One's on Leo Labs' new CEO, another on ASU expanding their space workforce programs to Australia and New Zealand, and another on a NASA spaceflight development contract awarded to Sierra Lobo. Hey, T-Minus crew, every Monday we produce a written intelligence roundup. It's called Signals and Space. So if you happen to miss any T-Minus episodes, this strategic written intelligence product will get you up to speed in the fastest way possible. It's all signal, no noise. You can sign up for Signals in Space in our show notes or at space.n2k.com.
Imagine a world where you're always one step ahead of cyber threats, where your defenses are impenetrable because you see what others don't. Welcome to Team Cymru's Threat Intelligence Solutions. With real-time access to the world's largest threat intelligence data ocean, they enable you to turn the tables on attackers. Transform your security from reactive to proactive through accelerated threat hunting and incident response, made possible through automation. Empower your team with visibility and insights to start defending your organization like never before. Team Cymru. Be the hunter, not the hunted. Learn more at team-cymru.com/cyberwire. That's team-cymru.com/cyberwire.
Our guest today is Matt Shieh, CEO and co-founder of Canopy Aerospace. And I started off my conversation with Matt in asking him how he came up with the idea to start Canopy Aerospace.
I spent my career in the Air Force, so I was a B-52 weapons officer. So that's like managing, operating, deploying weapon systems during flight. Did that for a number of years, and then went over to Europe as an air liaison officer, and that's advising U.S. NATO forces on how to integrate Air Force capabilities. So I saw a lot of the DoD from the inside, from the operational part, right, the end-use systems and cases of systems and things that needed to be built for us to enable our own capabilities to protect ourselves, defend the U.S., and most of all, defend partners and allies within the global environment as well. I decided to wrap up my career in 2020, headed to business school at University of Chicago for my MBA there. And I think like all veterans, took a little bit of time to figure out, where exactly I wanted to go in the private sector. And so a big part of me still wanted to contribute back to, what was the U.S. and a much higher calling and a mission out there. You lose that immediately once you come out of the military, which is very mission focused. So during my second year, I started looking at opportunities to build a business around a capability that would help the overall U.S. economy. And went through a few accelerator programs and went through one that's called FedTech out of DC, but they help partner potential entrepreneurs with federal lab technologies from 3 or 4 letter agencies and universities for potential commercialization. So through that process, I got connected with NASA's team that's been developing what are high temperature materials, thermal protection systems for spacecraft for the last few decades. And so this was a niche material that we found. We started building this thesis around the supply chain, a gap in manufacturing, and you have a new space race with new commercial assets today that need materials that don't exist anymore in the supply chain. And so these are flight heritage materials that we found that were still made through a traditional process. And so as we were building the company, raising capital, we needed to build IP around it as well. And so if we're going to stand up a traditional process for the industry, we wanted to build IP and make it more efficient and transition it to Industry 4.0 standards. And so that revolved around transitioning the materials to a 3D printable format, implementing robotics automation as well, and developing some software as well. So that led us to our first contract with NASA, where they're partnering with us to develop a 3D printable format of the legacy space shuttle tile. And that's a reusable heat shield that goes on a lot of different spacecraft today and in the future. And no one in the industry makes it today. So through that process, we started understanding, okay, here's an issue within a very specific part of the supply chain, which is around the design process, the manufacturing. It's inefficient, still, pretty low margins, pretty costly to make. And there wasn't really any progression that's been done, since for the last few decades. And so we took that model, and as we were learning about better manufacturing processes to implement in the ceramics industry, we started uncovering that, well, the whole supply chain actually within advanced ceramics has this problem across everything from rocket systems, satellite propulsion, sensor systems, ceramic mirrors, things like that, and then across terrestrial assets like the medical industry, automotives, power generation, semiconductors, and everything else. So ceramics go in a lot of different components and a lot of different subsystems and systems today that allow better functionality, better higher temperature requirements, and things like that. And so we developed a broader thesis over the last 2 years around fixing the entire manufacturing industry within the segment of ceramics. And so that's what's led us to where we are today, is standing up more of an industrial manufacturing model where we define our facility, our factory, and all the processes involved within the facility to actually fix what's the issue in the industry today.
My goodness, I'm listening to you describe the number of challenges that your organization's taking on, and I'm thinking just one of those would be a formidable challenge, but it sounds like there are a couple of them going on, and that's pretty amazing. Especially you mentioned supply chain resilience, and that is something that not just in ceramics, but in so many different areas, we've been hearing so much about that. But that's not just a since 2020 thing. That's been going on for quite some time. And this has become a real issue, especially in areas of national security and also just innovation. So thoughts on that?
Yeah, it's a good question. It's a thesis we've been building for a while, and there's a lot of other great manufacturing companies that have raised capital to tackle very specific parts of the market, from metals to plastics, from automating software, doing design for manufacturability, to 3D printing. And so recently what came out was the National Defense Industrial Strategy, which focuses on what are the problems within the industry that need to be solved, and that revolves around the industrial base. And when people think about the industrial base, they're looking at the supply chain as a whole is what we should be looking at it from. But most of the time, people are looking at it from very upstream at the design level, the integrator level, because those are the companies building the actual vehicles, the rockets, the satellites, the things that make the headlines in the news. But then if you start going downstream, layer by layer in the industry, to the subsystems, the components, the materials, and the raw materials, the government has found that every single layer needs investment and needs to be revitalized. My thesis is that over the last few years, a lot of investment has gone upstream, right, into the integrators, which are important. But then downstream is where a lot of the bottleneck is still happening, and where a lot of the supply chain is critically strained now, because you have so many people trying to build, but the manufacturing base isn't as efficient. You have a widening workforce and talent gap of about 2 million by the end of the decade. You have issues around, secure supply chain. We're trying to reshore a lot of our manufacturing. We're nearshore it, and just make sure, from raw material to component, subcomponent, and to the actual system itself, it's a secure supply chain from there as well. But for us, we're focused on 4 main things that align with it, and that's the advanced manufacturing part. So we do 3D printing today, but the larger, broader vision is around advanced manufacturing in terms of robotics, automation as well, and bringing all this together. The second part of our pillar there is advanced materials. So developing better materials that increase performance through a 3D printable method or through an advanced manufacturing application method. And then the third pillar for us is rapid testing and qualification, because you can make a new part, a new component, but depending on the industry, if it's aerospace, you have a lot of testing and qualification standards you have to meet. the medical industry, and like every industry is different. So bringing that in-house, trying to qualify faster, getting in the market faster is a way we can prototype new parts and get to production a lot faster than what's done today. And then the digital thread is developing better software so that we can make the current talent base a lot more efficient as well. And so the software are things that allow us to actually take what can be a 20 to 30 hour process for an engineer and then distill that down to 5 to 10 minutes on designing a part for manufacturability. And so that's leveraging AI, train the right AI models to help us basically automate the parametrics for manufacturability within components.
All of the things that you're mentioning, I mean, obviously Canopy alone cannot change the current state of U.S. manufacturing, although who knows? You mentioned the talent issue, and I was just thinking optimizing current talent is certainly one approach, but I'm wondering what you're thinking also in terms of this is a long-term problem, getting more people to be able to have the skills that are needed. I'm just curious what your thoughts are on that in terms of like the long-term vision, even just beyond Canopy, just in general, and getting that skilled workforce where it needs to be.
Our perspective and how we approach the industry is working at the intersection of government, academia, and the private sector. And so we've done that very well over the last 2 years, where we partnered with the Air Force, NASA, Missile Defense Agency, and other agencies in the pipeline right now that we're working on relationships with, but then also connecting that with the current academic base. So universities that have been doing R&D with incredible technology that's at the university level, but isn't ready for scale yet. And so that's where we come in. We partner with some of these universities, we partner with the government, and we find opportunities to commercialize and scale. But then also the talent base needs to be connected to that as well. And so for 3D printing, for example, there's no majors that focus on 3D printing. There's a handful of classes that you can take at the university level. But when these people come out, they have to go to a company that either does 3D printing or they go to one of the OEM manufacturers that make it. And there's just not a large base for that, but it's one of the largest, one of the most in-demand capabilities and talents that are needed. So we're working with local government within Colorado, standing up, what are like transition programs, technical programs and training programs that allow us to basically upskill the workforce here for 3D printing, because it's a very niche type of talent. Whereas like CNCs, for example, have been around for decades. So that talent base exists. You can find a lot of technicians within the workforce that do that. But for 3D printing, we're still in the very nascent stages. And so that's where it's a big focus for us, is to find the talent, build the talent, and then train. In the Air Force, the military, we had a concept called like train the trainers. So like basically build, capability of building more talent within our own ecosystem, because it's really hard to find outside, and it's much better if we just build it ourselves.
We'll be right back. Welcome back. We shared the sad news last month that the little helicopter that could, Ingenuity, affectionately known as Jenny, reached the end of its mission on Mars. On January 6th, Jenny flew 40 feet above the surface and then made an unplanned early landing after just 35 seconds. 12 days later, operators intended to troubleshoot the vehicle with a quick up and down test. Data from the vehicle indicated that it ascended to 40 feet again during this test, but then communications were ominously lost at the end of the flight. NASA declared the end of Jenny's operations on January 20th after an image captured by the Perseverance rover showed that at least one of its blades had sustained minor damage. And now, new images shared by Percy this weekend have been studied by a German student, Simeon Schmaus, and show that one rotor blade was completely broken off. The plucky little drone had far exceeded her mission expectations, but it's still sad to see that Jenny had her wings clipped. The blade was also seen in the images about 50 feet away from the helicopter. Now, with all the things in science, the end to the mission isn't always bad news. There's lessons to be learned here, after all. And the additional data will undoubtedly help the engineers and scientists who flew the helicopter to figure out what happened to the vehicle and possibly make the design of future flying vehicles on Mars and other worlds more robust. Ginny's legacy will live on, and we hope that the next generation vehicle will avoid the same fate. That's it for T-Minus for February 26, 2024. For additional resources from today's report, check out our show notes at space.n2k.com. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. We're privileged that N2K and podcasts like T-Minus are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K's strategic workforce intelligence optimizes the value of your biggest investment, your people. We make you smarter about your team while making your team smarter. Learn more at n2k.com. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Jen Iben. Our VP is Brandon Karp. And I'm Maria Varmazes. Thanks for listening. We'll see you tomorrow.